We are glad to be here in Windhoek, Namibia for the 5th edition of the African School of Fundamental Physics and Application.
2010, first edition, and that was in South Africa.
To Ghana, 2012, to Senegal, 2014, Rwanda, 2 years ago.
Been doing was to get different students from different countries in Africa.
There are several events organized during this African School of Physics in Namibia, at the University of Namibia and the Namibia University of Science and Technology, all coordinated by the National Commission on Research, Science and Technology. The programs that we have consist of a 3-week summer school, intensive school for university students. We have 85 students from 24 African countries, in addition to the US and Palestine. Then we have a professional physics conference whose objective is to bring back alumni ASP students, African researchers, faculties, to come and present their research work, discuss with the international participants, form new collaboration. The third part of ASP2018 is a dedicated 1-week workshop for high school teachers. We also have an outreach for secondary education, where within 1 week we are covering all the 39 high schools in the Khomas region of Namibia, upwards of 1,200 high school levels. Last aspect of the African School of Physics in Namibia is the ASP Forum, whose objective is to discuss how to better align the ASP program with the educational priorities of African countries. Here we invite ministers, educators, policymakers in matters of education. We invite our lecturers, teachers to discuss how to adapt the ASP program going forward.
We're delighted to welcome all the distinguished participants. Congratulations to all the students who gained admission to participate in the ASP 2018.
The accommodation, since we came, the accommodation at the airport, everything is fine. The people are great. Namibian people are very funny.
I would like to thank our sponsor,
ICTP, CERN, Fermilab, BNL, and many different other institutes have been our supporting institute from the very beginning.
And we didn't have to pay to come here, so most of the things are free. They applied for the visas for us, for those of us who needed visas, and they booked our flights and accommodations for us.
Thank our government for having put in the bid to hold this school here in Namibia.
The Ministry of Education, Arts and Culture in this country, in Namibia, realized the importance of physics knowledge and went far in terms of separating physical science to make it 2 subjects, namely physics and chemistry.
You take physics, go to chemistry and mathematics as well.
Encourage girls on the African continent to study. And eventually we also noticed that they were studying arts. We encouraged them to study science.
That we need to increase our investments in research, science, technology and innovation improve our capacities in research, science, technology, and innovation if we want to ensure a knowledge-based economy and innovation-driven economy by 2030.
The school is organized along 3 weeks. And the first week is about theoretical introduction to particle physics, nuclear physics, astroparticle physics, cosmology, and also an introduction to Monte Carlo generators.
So the moment that there was a big bang, we don't know what happened there, but then the next discovered, 1998, is called dark energy.
Why the name dark? Why dark?
Yes, dark in part because we don't know what it is. But we don't see anything by light. So that's the word we have called dark energy. It should not be confused with dark matter.
Suppose that they are particles. Now, if they are particles, they might have some kind of interaction. Okay, for example, a dark matter dust, speck of dust, it's enormous.
Participer à cette école d'été en Namibie, ça me fait énormément plaisir de rencontrer pas mal des étudiants qui viennent d'un petit peu de toute l'Afrique, interagir avec eux dans tout ce qui concerne ce qu'ils font comme études.
It's written in the first slide that the Klein-Gordon equation is the generalization of the Schrödinger equation.
Yes.
Yeah, but this it is taking into account the relativity effect.
Correct.
Yeah, but in the Schrödinger equation, we don't take into account the relativity effect. It is not the description of different systems, is it a generalization?
It's a direct generalization of the non-relativistic wave equation to the relativistic setting. So the relativistic setting is when it becomes important when energies are comparable to momenta, where speeds of particles are approaching the speed of light. Then, in that situation, E is not equal to P squared over 2m.
Ketevia Samagan, who is quite dynamic, also started a conference, which is the first this year in Namibia.
So we are very happy to host this event, and we feel that it will serve as an excellent way to promote research and innovation in Africa.
It is very essential to bring together experts in the field of physics, physics education and research, so that we can realize together the concerted solution to our challenges.
Probably this is the best platform for you to be able to pick up what you want to do, after your studies. What area do you want really to specialize in?
It's an opportunity for students to interact with each other, as well as to broaden their fields of studies. And if there are people that are trying to find a specific field of study of interest, then this is a very good opportunity for them.
Is it the way we see the world who drive us to a particular way of doing science, or is it the way we do the science which drive us to a particular way of seeing the world? Thank you.
When you look at the history, therefore history is very important to understand, is you have sometimes like fashions, yeah? Kind of, it's fashionable to measure certain things, although they might not have been relevant for the theory you were testing, but because the technology was available, we collected all this data. Yeah, so I think it is both.
And then the third week is based on application, which are as well some of the very important parts for the African community. Like, for instance, we have medical physics, radiation, and then any type of accelerator-based application that could be related in the same case for medical application.
Radiation. Why radiation? So based on this physics and chemistry, the introduction of charged particle therapy to treat patients.
Everybody obsessed trying to make the gas go round and round.
Yeah. But then blaster, what do you click to make the cat go round and round?
Well, you just click it twice.
Just click what twice?
Click the forever thing twice.
Click the forever?
We try from our side to give them
the best experience possible in such short time. First of all, exposing them to what professional meeting is, professional discussion with professional scientists from all around the world. We try to expose them to different opportunities and different options for their future career.
Indianapolis Motor Speedway is 4 kilometers per lap. So you can see the scale of things, right?
We have been mentoring students since then. Some of the students, when they come in, they keep in contact with the lecturers, and the lecturers willingly support them.
Astronomy has, different from most other fields of research, and not just in physics, but even of most other fields, has some very connecting nature altogether. You see, you find in literally every culture, you will find some sagas about what happens there in the sky.
You can create a biolayer of these systems, and it becomes a means of integrating these systems with these various different source materials. So it's an area of active research currently.
Because of this spectral effect. Otherwise, we can talk about power density, which is basically solar radiation per unit area. That is the radiation or the power falling on a given area.
We're talking about negative energy. In relativity, I've never been comfortable with the idea that the maximum energy has a 0 electron-volt, and they consider the energy below the maximum energy level to be negative. So I don't know how you can relate it to the concept of negative energy.
Negative energy it looks weird. And in the 20s, when they were working out those equations, they were saying, no, that's not possible. There must be something wrong somewhere. And the interpretation, the negative energy was just the manifestation of the entire particles. Like they are existing, they are connected to those solutions whose apparently the energy is negative.
Simulation of the gravitational waves, whether you could already see it in the simulations, if you can simulate the gravitational waves.
So there's very sophisticated computer codes for simulating what happens when you, for example, merge two black holes. So, for example, there's people in our group of Kings who do numerical relativity calculations. And experts in that can do these calculations, for example.
And I'm attending this ACP workshop, and I'm finding it really exciting, really challenging, because the level of the school is really quite good, and the level of the teachers is really, I can say, really high. So we have international.
To improve education in physics, physical education, even in chemistry, we must also include mathematics.
So, in fact, these next slides are the mathematical treatment of the classical model. So, the explanation of this wiggling and the emission of radiation.
Use physics and use mathematics as tools to better approach these problems.
So we have a probability distribution function. So this is a probability distribution, which means that it's a probability to have some variable x to be between x to x plus delta x, to be somewhere between here and here, say, in a bin. So it will be fx dx, it's like this area here, you understand me? So f is a probability distribution function, and fx dx is a probability. It's the probability to be between x and x plus dx. X can be anywhere here. Here the probability will be higher, and here it will be small, and here it will be small.
Today we did also tutorial on Linux, and I did Linux at EMS Cameroon.
It's just another operating system. Okay? So instead of using the graphical user interface, you basically communicate with the computer by sending text. Okay? So you're just going to work in what's called the terminal, anything that you do, whether you want to copy a file, you want to save it, you do all of that in a terminal by sending commands to the computer.
And it is also an opportunity for me this morning to help my colleagues, my fellow students, and to help them with some Linux code on Shell.
The organizing committee is very considerate. Ever since I came here, whatever I complain with, they just try their level best to remedy the situation. And about the conference, we are learning a lot. We are learning a lot of things that we didn't know before, the Monte Carlo generators, tutorials. Now I know how to use Linux, and yeah, it's just the best ever. So, yeah.
Materials in general are neutral in their natural state. If energy is provided to them, then you might be able to disturb them and have one electron moving away from where it is normally, where it is normally found. Then you get a job of negative and positively charged materials.
Well, of course, one thing I should say on mass is I'm talking always about the mass of fundamental particles. Quarks, electrons, muons, they are fundamental particles. Protons, neutrons, they are not.
Change the momentum of these electrons, there has to be a conservation of momentum, and that conservation of momentum is taken up when we generate photons. So you can think of it as we accelerate electrons to the speed of light.
There are several kinds of diagnostic to know in an accelerator if the beam is behaving as it should.
Our lecturers, they can speak both French and English fluently, and meeting students that speaks only French makes me feel like, wow, I'm missing out. I need to learn French because I really want to be someone that will be able to relate with students from all over Africa. So I'll be able to speak French to those that understand French and English to those that understand English. Thank you for coming.
Yeah, the program is really interesting here. We are learning many things apart from what I already know condensed matter physics. I also have the opportunity to learn more about cosmology, astrophysics. Yeah, the program is really interesting because people like us, we are many francophones, have the possibility to ask questions in French.
On va dire qu'avec les données actuelles, que l'univers est en expansion accélérée.
Oui.
Mais si l'accélération continue, l'expansion continue de toute façon, dans 1000 ans, qu'est-ce qui va se passer? L'univers sera comment?
Okay. So the question was, what is the relation between dark matter and dark energy, and whether they have some relation? And the answer is that they are quite different concepts. Because dark energy is something that is uniformly filling the universe. If you expand the universe, the density stays the same, where dark matter is acting like normal matter, in the sense that if you expand the universe, then the density of dark matter will decrease in the same way as the normal matter. And moreover, the dark matter could be described possibly by new particle, eventually SUSY particle, and would follow a Lagrangian, so it will follow some particle physics description, whereas the dark energy would not. It's just a constant of the universe, it's a property of the universe itself.
In cosmology, you have parameters that quantify the amount of matter you have. They quantify the amount of dark energy you have, and how the universe is curved.
I really liked it because we can ask questions everywhere, even if it's not during the lectures, even if it's during lunch. I really enjoyed it.
Okay. The goal of the standard model to consider the neutrino, the mass of neutrino is equal 0.
Yeah.
What is the goal of it?
The goal or the reason why in the standard model
it's equal 0.
Because we don't have the mathematical description that accommodates this. So we have this Higgs boson that tells us all the masses of the particles, but we cannot add an interaction with this Higgs boson and the neutrinos to give mass to the neutrinos, because it would be mathematically incorrect.
During the school, we also have a poster contest. Meaning that the students can present poster on the research activity that they have been doing with their advisors at their universities or research lab.
Like 2 weeks was an interaction between kids for 2 weeks.
Is there any, have we considered what happens when you collide two Higgs together? And yeah, this is a good question. The interaction of a Higgs with another Higgs is something that we want to look at, and it's something which we will be able to study, but not by colliding two Higgses together, but by making a Higgs decay to two Higgses, which you can, producing pairs of Higgses together. So producing, I mean, we can't make Higgs beams very easily. I mean, it's hard to think how you would make a Higgs beam, because you'd have to collide together either Higgses themselves or very massive particles like Ws or Zs, which again are all decaying very fast. But we can look, and we're interested. I mean, we will look at the LHC for production of two Higgses together, which basically comes because other particles couple to pairs of Higgses. So we sort of do it with the diagrams flipped in the other direction. But that's the goal for the HLLHC, for the long term of the LHC, which Albert mentioned. That it's something we need the full data sample of 10 to 20 years in the future to be able to start to study that. But yeah, we really want to do it. Yes.
To know the main difference between the pions and the protons or the nucleons in general.
I mean, of course, I mean, you can, the shower is determined, the details of the shower is determined by the cross-section of the particles to interact with the material which is in this volume. So it's true that, of course, if you look up in the cross-section of a pion with this material and the proton with the nucleus, is tiny, there's some tiny difference.
Before it's used in most of the experiments. It's also used in space science and medical research because it has interfaces with the radiation environment, for example, which is important if you are in a satellite. You have radiation cosmic rays that come into the satellite, the spaceship all the time. And medical research for
So we arranged our cards according to the metaparticle and its antiparticle, and we found that all of them were discovered on the same day except for the electron and the positron. So between the electron and the positron there was like briefly, I think 30 to 40 years of what's the bridge between before the positron was discovered. So I was kind of going wild in my mind why it took so long for the positron to be found, because, I mean, every matter particle has to have an antimatter particle, but, you know, I couldn't find the answer, so I'm still going to do my research on that a little later. Thank you very much for bringing me here. The program was very good. We learned a lot. We learned about different particles, antimatter and matter particles. Well, it was not really that long, but now we had a break. Well, it gave me this encouragement of not hating physics, because I was also planning on putting physics on extended, but now I've learned that no, I cannot do that anymore. Instead, I have it now on high level. This is very good, yeah, and we have learned a lot.
I know it's going to be beneficial because it's going to help me when I'm going to the tertiary, like at university, when I'm going to study. It can, sometimes we have a negative attitude about physics. With all of us, most of the people think that physics is very hard. But I understand it's not hard, it's just because we don't put more efforts to learn more about physics. But I believe we are really going to benefit a lot. Since we are having a break now, we are going to
tuvite umbiri n'enyanyu shitira kutarebapo kana skora na arongi yazaki rongo ya yoroka opoye yakufundinga mu African School of Physics.
On a fait une excursion qui nous a permis de se détendre et de prendre du plaisir et de mieux explorer la capitale de la Namibie.
120 billion euros for research and development must be spent. I think that this is enormously crazy opportunity. So please keep it in your minds. Start to be strategic already today.
The next edition of the African School of Physics will take place in Morocco in 2020.
Sexy girl, oh my